All right, diving right in, folks. We're going deep on a topic that's been bubbling up in our listener requests, synthetic data and AI, specifically how it's being used to train those large language models, LLMs.
Yeah, exactly. The LLMs.
And you sent in this super interesting research paper surveying the effects of quality, diversity, and complexity in synthetic data from large language models. I gotta say, I was really impressed with the insights.
It really is a deep dive. It looks at how those characteristics of synthetic data can actually make or break how well an AI performs, especially when it comes to stuff like reasoning and creativity.
Oh, yeah. Those more like creative tasks are becoming more important, right?
Huge.
And the paper really zeroes in on three main things: quality, diversity, and complexity. It's like we're about to find out the secret formula for the perfect AI, right?
hmm
So let's break it down. What are these characteristics all about? Like starting with quality, what does that even mean in terms of data?
So think of quality, like how precise your data is. Is it accurate? Is it relevant to what you want your AI to learn? Like if you're training an AI to write marketing copy, but you feed it a bunch of wrong info about the products, it'd be like using bad ingredients.
Yeah.
The final output, it just wouldn't be right.
So garbage in, garbage out, like data quality directly impacts the AI's output. That's
Exactly.
a pretty crucial point right there.
Yeah.
Okay. What about diversity? Why is that so important?
Okay, so diversity is all about giving your AI a wide range of examples. So you can think of it like if an AI only sees data from one tiny little source, it's going to be like a one-trick pony, right?
Yeah.
It might be amazing at that one specific thing, but then completely lost when it has to deal with something new.
Right. So like those chess AIs, right? They were unbeatable in chess, but ask them to play checkers and they'd have no clue.
Exactly.
Too specialized. Okay, so we've got quality and diversity, but where does complexity fit into this whole thing?
So complexity is all about how challenging or intricate the data is. It's like giving the AI brain teasers, pushing its limits. But here's the thing, too much complexity, and the AI gets overwhelmed.
Oh, okay.
It can actually make it harder to learn. So it's about finding that sweet spot, you know, the right amount of challenge.
Is that balance, right? And the paper mentions that it can be really tough to measure these characteristics precisely. Like, there isn't one perfect method. What are some of the things that make that so tricky?
Well, there are all these different methods out there, and each has its own strengths and weaknesses. So some researchers use these lexical measures where they're comparing vocabulary and sentence structure, in the synthetic data to real world examples. Then others will actually train a separate AI model, and that AI acts as a judge to evaluate the quality or diversity of the data.
Whoa, okay, an AI judging another AI. That's
But the thing is, it's tough to agree on these standardized benchmarks.
yeah.
It's like you're judging a cooking competition, but everyone has different ideas about what tastes good.
Totally. I mean, some people like spicy food, some people like bland food, some people.
Exactly.
So without a clear way to measure it, it's got to be difficult to compare different studies or even track how things are progressing in the field.
Yeah, you hit the nail on the head. It's a big area that needs more attention if we want to see real progress with synthetic data and AI. We need those agreed upon standards.
So we can all agree on what good really means.
Right.
Okay, so let's dive into how these characteristics, that quality, diversity, and complexity, actually impact what the AI learns, right? Because the paper seems to suggest there are some really interesting connections there.
Absolutely.
What did you find?
So one of the, I think, big takeaways is that, having that high quality data leads to better what they call in-distribution generalization. And basically that means the AI is really good at things that are very similar to what it was trained on. But the downside is it can be less adaptable.
Okay, so it's like training a chef to make the world's best, I don't know, let's say lasagna. They'll nail that lasagna every time, but ask them to make like a souffle and it could be a disaster.
Exactly.
It's too specialized.
And that's where diversity comes in.
Right.
AIs that are trained on diverse data, they tend to have better what we call out-of-distribution generalization,
Out of distribution. Okay.
meaning they can adapt to new situations, solve problems they haven't seen before.
Oh, that's huge. Right.
Yeah, it's super important for real-world applications.
If we want AIs to be actually useful in the real world, they need to be able to roll with the punches.
Absolutely.
And it sounds like complexity plays a part in that too.
Totally.
Yeah.
When you have the right amount of complexity, it helps the AI learn to tackle those really tricky problems, the ones that require a deeper understanding. The paper gives some really cool examples of how AIs trained on complex data can actually outperform those trained on simpler data sets.
So it's not just about like throwing a ton of data at the AI, it's about carefully picking that data to optimize how it learns.
Exactly.
And you mentioned earlier that there's this trade-off between quality and diversity, right? Can you unpack that a little bit more? I'm curious about how that works.
It's actually a really fascinating challenge. A lot of times when you like really optimize for one of those characteristics, it can negatively affect the other one. So think about a data set that's like super high quality,
Yeah.
perfect, polished, no errors. It might not have the range of examples that you need for good diversity.
Right, so it's like having a cookbook with only like 5 recipes, but they're all perfect.
Yes.
Technically flawless, but not very helpful if you want to make something different.
And then on the flip side, a data set that prioritizes diversity might end up having some lower quality examples in there, which could mess with the AI's learning.
Ah, so it's like a balancing act, right? Trying to give the AI both high quality data and a wide variety of examples. Okay, I'm curious. How do researchers actually make the synthetic data? I can't imagine they're just like typing random words into a computer.
No, no, it's definitely more sophisticated than that.
Right.
The paper breaks down the process into these three phases: generation, filtration, and distillation. And each step plays a role in, shaping those final characteristics of the data.
Okay, so let's take it step by step. What's the first phase all about? How do they generate that raw data in the first place?
Okay, so the first step is all about generation. Like
Yeah.
creating the raw data itself. And researchers often use those powerful AIs, like the LLMs we talked about, to actually generate that data.
So it's like using one AI to like train the next generation of AIs, the whole AI family tree.
Exactly.
And when they're in that generation phase, what are they doing to make sure the data is high quality?
So one approach is called chain of thought prompting. Instead of just giving the AI a vague instruction, you actually guide it to think step by step. Like, imagine a chef meticulously following a recipe.
Right. Yeah.
It helps the AI produce more accurate and coherent outputs.
So it's like breaking the task down into smaller, more manageable chunks.
Right. And then there's also meta prompting. This one's a little trippy, but it's like you're giving the AI instructions on how to write better instructions.
Oh, okay. So we're going meta. Using AI to train AI on how to generate better data to train other AIs.
Yeah, pretty much.
My brain hurts. That's really cool.
It can really boost the quality of the data, though.
Okay, so that's quality. What about diversity? How do they make sure the AI is spitting out all sorts of different examples?
So one thing they do is like feed the AI a diverse set of prompts to begin with. It's like giving a chef all sorts of different ingredients and seeing what they come up with.
So it's not just about what they ask the AI to make, it's about giving it a lot of different starting points.
Right, exactly. And they also use these like clever decoding strategies during the generation process.
Decoding strategies.
Yeah, so like it basically controls how the AI samples from all the information it has and makes sure it doesn't just get stuck in a rut.
So it's like giving the AI different techniques to use, like adjusting the oven temperature or using a different kind of pan so you get a different result.
That's a great way to think about it.
Yeah.
And they often use external tools to help the AI along too.
Yeah.
Like imagine giving a chef access to like a massive culinary encyclopedia or a calculator to get the measurements exactly right.
Oh, or like real-time feedback from like a bunch of food critics while they're cooking.
Exactly. All these tools help the AI produce better, more interesting outputs.
This is making me hungry. Okay, so they're giving the AI all these resources and it's producing all this data. But then it's time for filtration, right?
Exactly.
Like quality control.
Yeah, time to separate the wheat from the chaff. You want to make sure only the good stuff gets through to the training phase.
Right. So how do they do that? How do they weed out the duds?
Well, sometimes it can be as simple as like removing duplicates or anything that's not in the right format.
Oh, okay. So like a chef tossing out a wilted piece of lettuce.
Exactly. Nobody wants that. But, often they use much more sophisticated methods, like they might train a separate AI to act as a judge.
Another AI judge.
Yeah. And that AI can learn to like spot those patterns of good data and flag anything that doesn't measure up.
So it's like having an expert chef judging the dishes to make sure they're up to par. And I bet they even get feedback from real humans too, right?
Oh, absolutely. Humans are still the gold standard for judging things like good writing or good code.
Right. We have good taste.
But it's a delicate balance because, if you're too strict with your filtering, you might end up losing some of that diversity,
Yeah.
sacrificing those more unique examples just for the sake of perfection.
There's that quality diversity trade-off again. Okay. But what about complexity? How do they push the AI to produce those more challenging outputs?
So one technique is to have the AI gradually evolve its outputs to become more complex. It's like a chef who's like slowly mastering harder and harder techniques.
Okay. So like adding more layers of flavor and getting fancier with the presentation.
Yeah. And those AI judges or even the human feedback, they're really important here. They make sure the complexity stays within like a reasonable range.
Hmm.
You don't want the AI to get too ambitious too quickly.
It's like having a mentor chef there to like offer guidance and make sure things don't get out of control. Okay, so we've generated that raw data, filtered out the bad stuff. Now it's time for distillation.
Right.
And this is where they actually train the new AI.
Yeah. This is where the rubber meets the road, so to speak,
Yeah.
right? Where that synthetic data gets put to work.
And are there specific techniques they use to make sure the AI learns effectively from that data? Especially that more complex stuff.
There are a bunch. One that's pretty cool is called curriculum learning. So with this one, you're actually presenting the data in a specific order.
Oh,
Starting with the easier stuff and then gradually increasing the difficulty as the AI learns.
so it's like designing a personalized lesson plan for the AI.
Yeah, exactly. And there's also this thing called weak to strong generalization. The AI learns from those simple examples first, and then it moves on to the tougher ones. It helps the AI develop these like more robust and adaptable skills.
So it's like learning the basic grammar rules before you try to write a novel.
Exactly. And during this whole process, they often use techniques from reinforcement learning.
Reinforcement learning.
Yeah, it's basically, like a system of rewards and punishments.
Yeah.
The AI gets rewarded for doing well and penalized for mistakes.
And that keeps it on track.
Okay.
So it's very like hands-on approach to the whole training process. It's pretty amazing to see how all these different techniques work together to like actually shape what the AI is capable of.
It really is.
Yeah.
And remember, each of those phases, that generation, the filtration, the distillation, they can all be adjusted to control those final characteristics, that quality, diversity, and complexity of that new AI.
So it's not just about the data itself. It's about how you use it, how you shape it. This whole deep dive has been so insightful, and I'm really starting to appreciate the art and science of all this, but it definitely feels like there's still so much more to uncover. What are your thoughts on where all this is headed? Like, what's the future of synthetic data and AI?
Well, I think,
Mhm.
I think the possibilities are pretty much endless. As we get better at these techniques, we can create AIs that are not just like smarter, but also more trustworthy. Imagine AIs that can actually help us solve like some of the world's biggest problems.
It's exciting, but also a bit daunting, right? Like, there's a lot of responsibility that comes with that kind of power.
Oh, for sure.
Are there any specific areas that researchers are focusing on right now? Like, what are the next big things?
Absolutely. One area that's getting a lot of attention is the development of what they call quality diversity algorithms, or QD algorithms.
Yeah.
They're designed to tackle that whole balance between quality and diversity that we keep talking about.
Right, because we've seen how focusing on one can sometimes mean sacrificing the other.
Exactly.
So are these QD algorithms like trying to crack that code?
Yeah, basically, it's like think of a chef who can create a menu that's both incredibly delicious and has a ton of variety. That's what QD algorithms are aiming for.
Okay, I'm listening. How do they pull that off? It sounds pretty impressive.
So one of the most popular QD algorithms out there is called MAP Elites. It works by like dividing all the possible solutions, whether that's text or code or even music, into a grid
Okay.
based on their characteristics.
So it's like sorting all the possible dishes in the world by like ingredients, cooking styles, things like that.
Exactly. And then the algorithm goes through each part of the grid and looks for high-quality solutions in every category.
So it's like making sure there's a standout dish for everyone, no matter what their taste is.
Exactly.
This sounds insanely complex. How do they actually like put this into practice?
Well, they're combining MAP Elites with the power of those LLMs.
Oh, okay.
So the AI's generative abilities are used to like explore that massive grid, coming up with all these creative solutions.
So it's like our master chef now has a whole team of sous chefs helping them out, each one with their own specialty.
Exactly. And that's just one approach, right? Some researchers are actually training AIs to learn what diversity even means by using feedback from humans.
Oh, wow. So the AI is basically learning what good taste is based on human feedback.
Yeah,
That's so cool.
it's pretty wild.
Are there other ways they're tackling this?
Yeah, there's another one called QDAI,
UDAF.
and it uses LLMs not just to generate the solutions, but also to actually evaluate them. So it's like this constant feedback loop, pushing for both quality and diversity.
So it's like the chef is tasting their own dishes and making adjustments as they go.
Exactly. It's pretty amazing.
Okay. So we've talked about these QD algorithms and how they're pushing the boundaries of quality and diversity. But what about complexity? Where does that fit into all of this?
That's the next frontier, really. Most QD algorithms right now, they're focused on that quality diversity balance.
Yeah.
But figuring out how to bring complexity into the mix, that's like the next level.
So it's like our master chef now has to think about not just how good the food tastes and how much variety there is, but also how complex and like artistic the techniques are.
Exactly. And it's important if we want AIs that can solve these really complex real-world problems.
Mm,
Like imagine an AI that can not only diagnose diseases, but also like figure out new treatment options.
that's incredible. But getting there, it's not going to be easy, right?
No, it'll be tough.
Hmm.
One of the big challenges right now is that the ways we measure complexity are still pretty basic. They don't really capture the whole picture. Like imagine trying to judge a dish just by how many ingredients it has. It's just not enough.
Yeah,
So,
it's so much more than that.
exactly. And then the other challenge is figuring out how to create these QD algorithms that can actually handle all three things at the same time: quality, diversity, and complexity.
So we're basically asking our master chef to create this like multi-course tasting menu that's not only delicious and varied, but also features all these super complex techniques.
Yeah, it's a tall order,
Mm.
but the potential payoff is huge.
It's worth it. Well, this has been an amazing deep dive. We've gone from the basics of synthetic data all the way to like the cutting edge of AI research. And it's clear that the future of AI is very closely tied to how this whole field
Oh,
develops.
absolutely. It's an exciting time to be working on this stuff.
For sure. And for our listeners, we hope this deep dive has given you a better understanding of the power of synthetic data and AI. And, keep exploring, keep learning, and keep diving deep. Thanks for joining us.